The third one is the immunological surveillance. So this is pretty much equal to what the natural killer cells are doing. So basically, they are more likely natural killer cells. So these are white blood cells or whose job it is to kill your own body cells that are becoming abnormal. Well, they're not normal. So this happens all the time, and there are some people out there who the interference, well, they might be smokers for 40 or 50 or even 60 years or more and never get cancer. They just die, they just die of heart attack in their 90s or older than that. And you wonder, how did they not get cancer? Well, it could be that they have genetic factors making their natural killer cells just really awesome at their job. So anytime that something abnormal cell growth happened in the respiratory tract, the natural killer cells nip it in the bud and just destroyed it before it could turn into cancer. And on the other hand, some people natural killer cells are not doing the best jobs and they turn to be more susceptible to cancerous growths occurring. So this is a way that you keep body cells in check if they are or if they are not doing what they are supposed to do. Fourth, fourth one is the interference. These are chemicals that actually make it harder for something like a virus to keep spreading, and it actually will make cells in the region of where that virus is less susceptible to getting that virus coming to them. So interference, regardless of what kind of virus infection you are exposed to, the secretions, these little peptides, these protein bits, they are going to make it so that you're more likely to defeat the virus. The fifth one is the inflammation. The inflammation, whether it's an allergy, bacteria, virus, or whatever inflammation is your immune system responds to, like, it's swelling thing if something is in your bloodstream. It doesn't belong there. There's gonna be a stimulation to expand the blood vessels in the area to get more blood flow in terms of volume, and that's going to get more white blood cells to the area. And the more white blood cells go to that area, well, the more likely it is you're going to get rid of that infection quickly. The sixth one, or the last one, is our the fever. So guys, fever happened, and honestly, they are very uncomfortable. That they are really, really uncomfortable. But you know what, guys? It serves a purpose. It really does. So here's the Celsius scale normal. It depends on the person. If we're talking about Fahrenheit, it's gonna be a different number, obviously. But you know what? 37 degrees Celsius. That's high. About 90 plus 98.6 Fahrenheit. Is what the normal is what a lot of people say it's normal. Well, my normal is 98.2 Fahrenheit. So some people might be 98.3 Fahrenheit is their normal baseline. And regardless of what you are in that 98-degree range, your regular body temperature is gonna be about 37 degrees Celsius. And if it's get up into high 37 or 38 degrees or even 39 degrees Celsius, well, you're probably talking about a fever. And that usually means that you are sick with something substantial. So the fever, if you're wondering why it does happen, why does our body heat go up? Well, it makes harder for the virus or bacteria to spread in that hotter environment. So it does serve a purpose. It really does. And even though it causes us some discomfort, and we had up sweating a lot, and it's just not pleasant, but it does serve a purpose. It really does. Well, there are medications that will reduce your fever, just reduce, but still enable white blood cells to get the job done. All right, so now let's proceed to specific defenses. You already done tackling about the non-specific defenses. Now, specific defenses. So depending on the particular type of pathogen, you're gonna have very specific kinds of reactions. So this is also known as immunity, as I've said in the previous slides. Well, it um, this is known as immunity. So when you became immune to something that we're talking about a specific defense, so this is the coordinated activities of B cells and T cells. So here's the two kind of immunity, the innate immunity and the acquired immunity. Now let's first discuss about innate immunity. Well, innate immunity, it means you're born with it. It's innate. You're born with the ability to react to two different things that you are exposed to. You can change that. That's based on genetics. But a lot of immunity is acquired. When we see acquired, it's picked up just by living by your being exposed to different pathogens or foreign bodies. So when we talk about acquired immunity, is really what you gain as life goes on. You could probably talk about as you can see here, the active acquired immunity and the passive acquired immunity. So let's talk about active acquired immunity. How do you naturally acquire it? Well, a good example of that is think about a baby that's just been born and they get exposed to something, some germs. That's an example of how a baby can naturally acquire active immunity. So the baby's, sucking on something that had germs on it, well, introducing that bacteria from that toy, whatever they had in their mouth. So that's gonna allow their white blood cells to identify, be like, oh, okay, now we know what this is, so we will be able to prevent it spreading the future. So something like that. So that's just being exposed to stuff in your environment. When we say induce active immunity, is vaccination. So if you get an immunization, well, immunization is another term for it. So a lot of kids these days are immunized against, for example, chickenpox. When I was a baby, they didn't have that in wide distribution in terms of getting a shot that gets rid of the chickenpox in the future. So as I remember, I get the chicken pox when I was about 7 or 8, I think, and chances are I'm not gonna get it again because I have cells that have retained a memory of what the chickenpox virus was, or what that chickenpox virus was like. If I'm exposed to it from someone in my environment, I'm not gonna get sick again. However, some people do get sick with chickenpox more than once because sometimes the second exposure. So mainly because the chickenpox the genetics of that particular chickenpox virus was slightly different. So that's it's not quite the same kind of signaling that your body is used to. So you might get sick a second time around. But if you've been vaccinated, you've been exposed to bit to the dead virus, it's like exposing your body to the non-active form of the virus. They look at the proteins oh, okay, that's what this thing's made of, and they're able to kind of certain a memory of what's that like. So you're exposed to the live active virus from somebody touching you or whatever, then you're probably not gonna get sick. Now, moving to passive acquired immunity, one example of it is passive acquired immunity in terms of it being naturally acquired is when you're a baby getting antibodies from your mom. So not the natural surface of the virus or surface of the bacteria. You're getting antibodies either through the placental connection, which you hear more about in the embryological lessons, but The placenta is how a baby gets its blood, and I'm going like this with my fingers because there's this connections that allow the mother's blood to end up going in into the placental side that goes with the baby in through the umbilical cord, and that's how the baby gets all its oxygen nutrients while it's developing. So sometimes you can have antibodies crossing through the placental barriers, so the baby is born with antibodies against some kind of bacteria. And that's amazing thing about. Also, breast milk can sometimes have antibodies coming out from the mothers through the breast milk in in the bodies in the baby's body. So that's a naturally acquired passive immunity. Then, if we talk about induced passive immunity, induced passive immunity would be something like you can actually inject antibodies into somebody rather than injecting like the surface of the virus or something like that. So rabies, if somebody may have been exposed to rabies, right? So rabies is an example. So if somebody may have been exposed to the rabies, so you can inject antibodies into that person's bloodstream to help them deal with that particular infection. So that's it. That's the non-specific and specific defenses.